think I'm ready to go. Good morning, everybody. Morning, Brooksy. Who else is out there? Morning, Vince. Okay, so next to last lab. This is a two-parter, so we'll go as far as we can get. I think probably we can get both parts, but we'll just see. So, morning, Daisuke. So we'll do the first part of the lab and then the second part of the lab. The objective of the first part of the lab is to get these buttons working, and all the buttons do is they increment and decrement a counter. That's all they do. But we will display the values. So the buttons will be attached by software to a counter variable, and then the value of the counter variable we'll use to decide what to display on the white, the clear or multicolored LED. So here's my board from the other day. From Tuesday. Hopefully you had a chance to wire yours up. It's a complicated one and kind of looks like a rat's nest. If you are more artistic than I am, you probably have something that looks prettier. But just need it to work. So the buttons, you just have to be careful when you're operating them to sort of, don't mess up your circuit when you click the buttons. Anyway, so let's get started. So I've already done it. If you haven't done it though, Lab 15 has a bunch of pieces. So the part 1 will be the main1.s, config1.s, and macros1.s. But basically if you download all of the files into a folder, and then we can just target the part 1 files as needed. The config files, we don't actually have to write any code in. They just sort of add some things for part 2. Macros, though, we'll have to code, and then main we'll have to code. So hopefully you're all set up, but I'll dawdle a little bit so that if you aren't, you have a chance to download those files into a folder. And then get yourself to main1.s. I noticed I had a numbering problem on it, so we'll fix that. I fixed mine because I just couldn't stand my numbers being off. What you'll notice though is the includes. So notice the includes for main1.s are macros1.s and config1.s. So those files, as long as we save them with those names, then everything's just going to work as long as we fill in the code. Okay, so this first look at interrupt handling is there's just a whole bunch of new stuff that you're going to see in the code. On Tuesday next week, we will go back and sort of talk about what these new things really are. But you'll notice there are a lot of Nucleo memory banks, memory registers, or configuration bits getting touched in this lab. Most of the configuration, and probably all of it, I've already done for you, but we'll look around a little bit. Anyway, there's a lot, but those are all already filled in, so that's just something to stop and look at. And then we have something new here. We've had the V table before, but we didn't have the V table with so much stuff in it. So this is V table stands for vector table. And again, we'll talk about the details of this on Tuesday. But basically, this is sort of a pre-wired mapping of interrupt handling signals to the processor. So remember on Tuesday we talked about hardware interrupts. And what a hardware interrupt really does is it sends an electronic signal to the processor. So in the world of ARM, the kinds of electronic signals that it will accept from hardware devices is already pre-wired into it. So all we have to do really is identify which of those electronic signals we need to use and then write some code for that. So I've already written all the code, just kind of so you know. This is a table that maps electronic signals to internal functionality. We've already seen the stack setup and the reset handler, so we've actually always been dealing with that interrupt. When you click the black button, that sends an interrupt signal to the processor, which causes it to reset and reboot itself. And then you'll notice there's a whole bunch of blanks here. And basically, these are all interrupt signals that we have no interest in. Some of them don't have any defined usage. Some of them are there to detect hardware failures, so that the hardware actually sends an electronic signal to the processor if something fails. And if we go down here way to the bottom, we get to the part of this mapping where we can actually connect pins, wires on the Nucleo board to the processor as an interrupt handler. So that's what those are. And then basically what we do with pin 0 handler and pin 1 handler is that gives us the ability to define a function that is the interrupt service routine, which we talked about a little bit. So pin 0 handler is the function that is called automatically when the processor receives an interrupt signal on a particular wire. And then pin 1 handler is the function that the processor will call automatically when it receives an interrupt signal on that particular wire. These signals are all sort of pre-mapped, so you have to figure out which is the correct place to connect your function to the signal. So I've already figured that out. So we want to be able to handle for our two buttons, two different interrupt signals, and then we'll connect those to functions in our code. So that's a lot to take in. Don't worry tons about it. It's already been done, just so you kind of know. This is a table that maps interrupt signals to functions. And most of them we just completely ignore, which you're allowed to do in ARM, so I don't care about that interrupt signal. I'm not going to do anything. Okay, so here's the interrupt or the reset handler function. You can kind of see that, by the way. There's the reset handler that we connected to that interrupt signal, and then it is a function. You can even see the word there. So this is what happens. This is the function that the processor will call when it receives the interrupt signal from the black button. So we want to add two new buttons, so we're going to add two new functions that cause the processor will call when it receives particular interrupts. So one is the pin 0 handler. So pin 0 handler, and that's here in the vector table, the mapping. And then here's the pin 1 handler function. So this is what happens when the processor receives that interrupt signal. It will call this function and cause this code to execute. Not too big a deal. We still have a debounce on the button, by the way, but that's a macro that I've already written. Most of the code is already written, except for now we need to call a macro from in here. So let's do that. It's called Increment Mode. I'll show you where the macro lives. It's in macros 1.s. So here's Increment Mode. Takes one argument, which is a mode variable. So it also tells us to do that. Pass the mode variable. I'm going to save that. I'll show you where the mode variable came from too. So increment mode is a macro. The mode variable is way up. I'm on line 100. It's way up here, right here in the data section. So there's the mode variable, and that's a counter. So the buttons are going to cause that variable to count up and count down. Notice that it starts in mode 3. or at the value 3. Okay, so that's all that is. It's just simply a variable. So we pass that to this macro, that's step 1. And with that, we've completed the pin 0 handler service routine. So that's what happens when a particular interrupt signal is sent to the processor. Now let's go down to pin 1 handler. Hopefully everyone got that when I went fast. Okay, pin 1 handler. This used to say number 1 on it right here, by the way. That should have been number 2. Called Increment Mode macro. And pass it the mode variable. That's it. Which completes the pin 1 handler interrupt service routine. All that really tells us, by the way, is that when you click one button, it increments that counter, and when you click the other button, it decrements the counter. That's all it means. And note, by the way, be careful, that's decrement underscore mode. Underscore mode. Same for increment underscore mode. That's the name of the macro. That's the name of the variable that's being passed as an argument to the macro. And let's go find number 3. So here's the start of the program. We're actually at the bottom of the code already. Configure interrupts is a macro in config1.s. Configure GPIO is a macro in config1.s. We can go look at that. Config1.s. Here's configure interrupts. That's already been written for us, meaning I wrote it because it was complicated to do and I didn't want to leave any of that in doubt. Plus it's kind of busy work. So anyway, there's configure interrupts macro. Pushes a couple of registers and then does a whole bunch of configuration stuff. And then if we go down there, we also find configure GPIO, which is another macro, pushes and pops some registers and then does some familiar configuration work. That's where those came from. So configure interrupts, configure GPIO have already been written for us. They're macros in the config1.s file. The last part of main1.s is simply to call the display mode macro and pass the mode variable. So main in this case is super easy. It's just 3 macro calls. And again, display mode underscore underscore. So there's just 3 things in main for part 1. And if you need me to hit pause or go back, just say in chat and I'll do that. I'm trying to pace myself with the little time delay between me saying it and you hearing it. So just let me know if I need to take a step backward, it's fine. Okay, so let's go work on macros1.s. So main1, macros1, config1, they all go together for part 1. But we only have to write code in main1 and macros1. Config1 has already been completed. Okay, here we go. So number 4 is to complete this macro. And I'll just sort of explain what I've done here and then I'll write the code for it. So the reason why I named the parameter mode var is because I wanted to remember that this is a variable in memory. And a variable in memory requires different treatment in code than a register does. So mode is going to be a variable in memory. So how do we decrement a variable in memory? The first thing to do is to load up the address of the variable. So we have to do some funky code here. So to get the variable from the parameter, we put a backslash in front of it, just like we did before, but we need the address of it since we know that it is a variable in memory. Second step is to dereference that address and get the current value. So also fairly straightforward with a little bit of sort of funkiness around the address and getting the parameter in the macro. So get the address, dereference the address to get the value, change the value, which in this case we're decrementing, so we're just going to subtract 1 from it. And then store it back. Now I know we have some logic to do, but this is the basic routine. And then we're going to add some fix-up logic around it to deal with the don't go below 0 thing. Okay, hopefully everyone's good. So now let's go fix up the logic, because we don't actually want to do this subtract if this value is already on 0. So I'm going to do a comparison here. So, and I'm going to compare R1 with the value 0. Yes, we do, Brooksy. So we do need to go do a push and pop here before we're done. So good catch. And I usually leave the push and pop to the end so that I sort of, by the time I do the push and pop, I know which registers I'm mucking around with. So, but good eye. And keep that in mind because I do tend to forget that. But also I usually try to do that last because I just sort of wait and see which registers I used. And then do my pushing and popping step as the last thing after I know what all the registers are. Okay, so we're going to compare. Do I want to compare here? I think I do want to compare. And what I want to know is if then, I'm going to use HI, which is greater than for unsigned ARM variables. So if R1 is higher than 0, then it is safe to subtract from it. And I think it's cute that it says high. So before I do the subtract, I'm just going to compare R1 with 0 and only subtract 1 from it if it's higher than 0. So that's an if-then block on a higher than outcome. So it's entirely possible that I'm storing the same value back that it started as, but I'm fine with that. Okay, so let's do the push and pop stuff too. So I used R0 and R1. So good call, Brooksy. Push R0 through R1, and then make sure we pop that R0 through R1 at the end. You think we should, I think we should compile. Let's compile just to make sure that we haven't made any big mistakes up to this point. So I am going to go, I'm going to go to the recipe and just grab this first, the compile step. I need to hide the camera so you can see this part. And then for the compile step, just be careful here because we're working with main1.s. Nothing else changes, but we're working with main1.s. But anyway, we're just going to hit it with the compiler, and if we made any mistakes, we can clean those up. All right, so I'm all good. If you're getting a compiler error, let us know in chat so we can help you fix it. Don't know if it works yet, but it compiles. All right, hopefully we're ready to go on to increment mode. So we're going to use the same process. We can probably anticipate that we're going to push and pop R0 and R1, but I usually just wait just in case I decide that there's another register that I need. All right, so same process. The mode is coming in as a variable in memory, so we have to do the steps of getting the address of that parameter. The backslash is because that's how you access macro parameters in GNU assembly. Get the value by dereferencing that address. So now we know what the current value of the counter is. This time we can do the logic up front. So let's compare R1 with 3 this time, because it says don't go over 3. So in this case, we're only interested if R1 is lower than 3, which is what the LO means. If R1 is lower than 3, then it is safe to add 1 to it. I'm going to push these over just because I think it looks better when they're lined up. So there's an if-then block after that comparison. And we're only going to add 1 to R1 if it is lower than 3. That'll cap it at 3, right? If it's at 3, then it won't increment it. It'll just stick. Then we store that back. So then we store R1 back into memory. And then let's do the push and pops. So we used R0 and R1, and then we will pop those. And then I think it's wise to just go back real quick and hit it with the compiler and make sure we didn't make any obvious mistakes that the compiler would see. And again, just be careful to make sure that this compiler command is referencing main1.s. None of the other stuff has to change, but main1.s. So for me, all good still. So one of the things that's kind of hoped, at least by people like me, is after you take an assembly language course and you see what it looks like, then you no longer hate C++ so much. You think actually C++ is all right to take away most of this mess. All right, that's number 5. Let's see what else is left. 6, 7, and 8. All right, you're going to see some little syntactical funninesses here. These \@ on all these labels. If I have time, I will explain what those are doing there, but when you put a label inside of a macro, putting this \@ on the end of the label can save you a headache. What this does, basically every time you call a macro, it just makes a copy of this code wherever you call it. So if you call a macro more than once, you get 2 copies of the macro, the code. And if you get 2 copies of the macro and you get 2 copies of the same label, you get errors. So what the \@ does is every time you call the macro, that \@ actually is a little counter, and it just adds an extra number on the end. So the first time that you call a macro, this label is going to be copied as mode 0, 1, and then mode 1, 1, mode 2, 1, mode 3, 1, and end mode 1. And then the second time you call the macro, that \@ becomes a 2. So you get mode 0, 2, mode 1, 2, mode 2, 2. So that keeps the labels from tripping over each other and makes them all have a unique name. So it's just a little macro trick um, that eliminates some headaches. Otherwise, don't worry about it. We just have some work to do on 6, 7, and 8. So mode 0 doesn't do anything. So when the counter's on 0, the light won't come on. All right, so mode 1. How do we know that we got to mode 1? How are we getting to this label? Mode var equals 1. Oh, okay, I get it. Just check to see if mode var is 1. So, all right, so here we've got to pay attention to what we're doing because the mode var has already been loaded up and its value is in R1. So mode var value is in R1 and we want to see if it is equal to 1. If it is equal to 1, then we have something to OR. PC2. So let's see, where is the PC stuff? So here's the PC stuff. So the value that we're manipulating is in R3. Probably most of you can kind of track this at this point. The mode, the counter is in R1 and the LED value is in R3. Notice, by the way, it clears all the LEDs before we get down here. Okay, so anyway, R1 is the counter that we test, and then R3 is where we do the settings. So PC2, that one's pretty easy. That's C2 is just not 2 to the 0, not 2 to the first, but 2 squared. So that. 4. So that's pretty easy with an if-then block. Number 7, so that is testing to see if, we'll line those up, if R1 is 2. If it is, then we will hit R3 with what, PC3, right? Yeah. So that's 2 to the third. And then if it's 3, so counters in R1, checking to see if it's at 3. So the mode can be at 4 values. It can be at 0, in which case nothing happens. If it's 1, then one of the lights on the clear LED comes on. If the counter is on 2, then the other light comes on. And if the counter is on 3, then the combination of those two comes on, or is supposed to. All right, so it's R1 3. If it is equal to 3, then we want to OR something. And what are we hitting? Oh, PC2 and PC3. Okay. PC2 and PC3, so both of them. Which is 12, which is C, I think. Someone can check me on the hex there. Okay. It's just not, sometimes the brain's just not fully in gear, so sometimes those are easy to mess up. So it's I have the advantage of having all you guys here to sort of error check me as we go. I don't know what's going on with that. Okay, so let's do the recipe then. So I'll run the compiler, and then I have to go get the rest of the recipe. So only the first one has to have main1.s. The rest of them just take care of themselves, right? So compile elf. Oops. Oh no. It's going to have a mess on it. Okay, elf bin Now I got to plug it in because I can't flash it if it's not on power. And then I'll show you my board. Come on, man. Okay. Random stuff from last week's lab. Okay, so I'm about to flash it, and then I'm gonna show you my board and show you what I hope is happening is. I hope what I want to happen happens. Flash the board. So jolly good. Okay, so here is my board. Because the mode was in 3 to start, you can't see the color, it looks kind of funny, but because it's in mode 3, it's actually showing the combination of the 2 colors to start. And then I don't know which of these buttons goes down and up, so I'm just going to have to experiment. One of them can't go up above 3, so in theory, yeah, so this is the up button for me, and nothing's happening when I press it. The down button, in theory, should count down, which should change this color. Which for me is doing nothing, by the way. I might have the buttons wired wrong. Yeah, mine's doing nothing. I don't know if everyone has got a nothing like I've got a nothing. But I've got a nothing. So it appears to me that the buttons aren't working. So that's a bit of a concern. So I'm paused to think on it for a second. Yeah, I think I have a wiring mistake. So see, a leg goes to hot. That seems all right. Oh. Well, at least yours does something, but I have a wiring mistake, and now I realize why there was an extra wire sitting on my board. I never actually powered the bus, so this positive bus right here, for me, I never actually connected the power bus, this red one, to the 5-volt feed on the board. I forgot to do that part. So I'm connecting a wire to the hot side, which is where the 2 buttons go, and then I need to connect that wire to 5 volts. And then I'm going to reset and see what happens. All right, so Vince and I have the same thing. It does move once. Wait. Okay, so I had blue. All right, I'm not happy right now. Using the right bind starts yellow, then red, then green, then off. So Brooksy, what did you do? Because that's correct. So that's what we want. It should cycle off and then 3 colors. Mine only sort of vaguely works. Just vaguely works. Now I'm looking to see if I made a mistake. I feel like I did. I think I did make a mistake. Although in theory, why couldn't I have just... No, I didn't. I didn't make a mistake. Reset. There's blue. All right, so followed your code and burned it and it worked. So why is yours working and mine's not working? And also Vince's is kind of similar to mine. So I'm going to tell you what I'm going to do is I'm going to just manually do the different modes and see what the different modes should do. Yeah, I'm looking to see if maybe my button's not in there all the way or something, which is entirely possible. It's also possible that I have a resistor not in, a button not in. That's max, so this should go back down. Well, I'm envious. I'm envious of Brooksy's thing, but I'm pretty confident about the coding part. I'm not confident about my circuit, which I feel now must be broken. It's possible I didn't get the buttons in. I have that on 5 volts. I do see one resistor that looks a little funny. Reset. All right, so I'm going to do this experiment just to see if my code is working correctly, other than the button part. I'm going to go change the mode. I'm going to go back to main1.s, and I'm going to just... I switched my 5-volt wire goes into the breadboard and it seems to work better. Well, is anybody else having luck but Brooksy? I know the circuit works. I mean, we've done this circuit in this class before. So I have a connection issue, I'm pretty sure. All right, starts in mode 3. Mode 2. Well, I've got something wrong. Increment mode, decrement mode, display mode, and the macros I think are all solid. It's higher than 1, subtract. If it's lower than 3, add. display the mode. Mode is 1. Mode is 2. Mode is 3. Stores that back. That should be all okay as far as I know. Well, I'm not having any luck. So that went down. I think this is my down button. Could be a logic thing. Can I go up? Yes, I can go up. I can go down. PC A1. I'm checking all my connections, everybody, because something ain't right. Mine's not working. My wire's wrong, so I'm redoing. Me too. Let's check wires. Because something funny happens when I take one of these buttons off. A0 is just completely off. How could that possibly be? No luck for me yet. What time is it? Well, I'm not going to waste your whole day on this. Should be doing it. That could be. I am going to try different buttons. I mean, that one came out just too easy, I think. I'm checking my buttons. I don't know, everybody. I guess I'll change this button out too. And then check to make sure that I'm actually in everywhere, which I appear to be. Try some different posts. I've got a circuit problem. That's true. That I put a 10, right? A 10K. This is a bummer. Button resistors are 10K ohm. So I am going to do, that's a good suggestion though. Make sure I get 10K ohm. 10. Ah! I did put the wrong resistors in. Look, here's my 10K strip. 10K strip. I didn't use that at all. My resistors on my buttons are the wrong stinking things. 10K. You probably did what I did, which is I took the one that said 10 on it. Which would be wrong. $10K. Holy moly. That's the countdown button. 10K ohm. I put 10 ohm, not 10K ohm. Look. Brooksy, you saved the day. Thank you. Look. Look what I did. So here's what I did on Tuesday. That's 10. Can't get it to show the 10, but there's 10. That's what I did on Tuesday. Here's what I did today. 10K, because that's what it says. Except for I didn't do that, and like magic, it works. So here's my up button. I'm on mode 0. Mode 1, which is green for me. Mode 2, which is blue. Mode 3, which is green and blue, which sort of is like a whitish blue. And then if I click it anymore, it doesn't go up. Here's my down button. So I'm in 3. I will go down to 2, which is blue, down to green, which is 1, down to not lit, which is 0, and it won't go any further. So 10K, unless you're stupid like me, 10K means 10K, not 10. 10K. 10K is 10,000, which you probably knew. Oh my God. Brooksy, thank you, man. You saved the day. I'm not joking. It works. Okay, so I hope everyone else got that working. Let me know if you need a break to see how much we can do on part 2. So anyway, if you read my diagram and followed it like I did not do, then it would have just worked. If you followed what I did and used 10 ohm resistors, then it doesn't work at all. Because that's important. 10K ohm. I even put it there, 10K. Okay, so have I made it so everyone needs a break, or can we go look at part 2? Let's see what's involved in part 2 and see if maybe we need a break for a minute or two. Part 2. Yeah, indeed I did, didn't I? And then I like thought, is it a bad button, or just go back and check the diagram. It's amazing though, isn't it? How much of a difference, I mean, that's completely the difference between it working and not working. Wow. Okay, so what I would like to do, if you guys are okay to proceed after that mess, I'm gonna open up main2.s and do the stuff in there. It's mostly the same except for there's a little bit extra at the bottom. And then we'll go do macros so anyway, I'm gonna do main2.s and then go grab some water to let you get a breather. And then we'll do macros2.s. Boy. Okay, I'm tired after that. So I'm in main2.s now. I'm gonna fill in number 1 is increment mode, pass the mode, that's the same. You can't see my code. You cannot see I'm back in the code. So I'm on main2.s now. And I'm just going to fill out these sort of quick and easy ones and then go grab some water and let you catch up a little. So number 1 in main2.s now, I'm in main2. Increment mode. Number 2 is decrement mode. Same thing as before with the mode variable. Number 3 is populate array macro. All right, so populate array. I'm going to put an extra blank line in there. Pass the numbers variable. So I'm just going to scroll up. And I expect to find an array declared in here. So there's a whole bunch of stuff. There's a mode. There's an offset. There's actually a counter now for the number of elements in the array, which will be 10. And then the array itself, numbers. So on number 3, when it says to populate the array, pass numbers, that's all I need to do there. Number 4, call the display mode macro and pass mode. And then this one's a little more complicated. 5 and 5a, but 5 and 5a is basically a related piece of logic. So this one's a little bit more involved. Oh wait, let's go do let's do 5 first. We'll do 5 first, and then we're about to take a break for a couple minutes. Check the mode, if mode is 0. So to check the mode, I'm first gonna have to get its value, I think, into a register, so let's do that. Gonna have to first get the address of mode and then the value of mode by dereferencing the address. Now I can see if the mode is equal to 0. So the value of mode is now an OR1. I can see if that's equal to 0. Let's not do, I don't think I like that. Let's do a compare instead. So I'm going to compare R1 with 0 to see if it is 0. If it's not 0, then I'm going to get the hell out of here. and then if it is 0, I won't have jumped. Hopefully that makes sense. So those first two lines are just getting the address of mode, using the address to get the value, and then comparing the value of mode with 0. If it's not equal to 0, then I'm done in this section, but if it is equal to 0, then I won't have branched, and I can call the display array macro passing numbers len offset. So it just tells me to do that, so I'm doing it. 3 arguments to the display macro. And then it will naturally flow to end mode. And then I can call the clear bits macro. Come on, video. What you doing? Okay, so I think this is a time when we can take a short break, so I can rush get some water. You can get some water. If you'd let me know in chat while I'm getting water, just if your buttons are now working because you listened to Brooksy's advice and not mine and used the correct resistor, which I've now done on my own. But anyway, please let me know in chat if your buttons are now cooperating, so that I know whether or not we can move forward to macros 2.s yet or not. So I'll leave that code sitting there, but I'm going to go grab some water real quick. All right, Vince, that's good news. All right, be back, and then everybody give me a check if you're good to go. Okay, I hope we're all doing okay and the buttons now work. So I was going to be very upset if it was some flaw in the circuit as I diagrammed it, but it wasn't, so thank goodness for that. So I know Brooksy and Vince's are working. I don't know how everyone else is doing, but hopefully you're doing okay. So we can move on to macros 2.s and knock this lab out. This is building blocks for the final lab is just going to build on this. So once you get that circuit working, then don't touch it, because we're going to use it again for the final lab of the semester. Okay, so we are in part 2, at least in theory. Part 1 gets the buttons cycling through the 0, 1, 2, and 3 modes up and down, and then the light changes to show that the mode has changed. So now we're in part 2, so now we're working in main 2.s, and then we're also going to be working with macros 2.s. Config 2 doesn't have anything we have to do in it, but I'm going to pull it up and I'll just look for us. So config 2 we don't even need this timer, to be honest, but config 2 is complete, so you don't have to touch that. You can just leave that alone. And we'll just work in main 2.s and macros 2.s. Now, if you want to, you can copy and paste this, but I'm going to re-implement the code just to make sure everyone could follow. So decrement mode, it's the same decrement mode. It's coming in as a variable in memory. So first thing I'm going to do is grab the address of it, grab the value of it, do some logic. So I will compare that value with 1. So in this case, if it is or 0, sorry. If it's above 0, then it is safe to subtract from it. And then we'll store that now updated value back into memory. And then add the push and the pop stuff. So it's the same macro. So you could have copied and pasted it if you wanted to, but in class I usually just think repetition helps some of us, myself for example. Same decrement mode. We just compare R1 with 0 and we only subtract if R1 is higher than 0. Same one though. Number 8. Number 9 is increment mode. So I already know, well, I'll do it the same way. I'll do it the same way. Get the address of that mode var. Yeah. Get the value of that mode var. And then I'll compare that with 3. And only if it's lower than 3 will I add to it. And I just like to line these up. But it's precisely the same macro as we did before. Precisely the same one. And then since I used R0 and R1, I'll push and pop those. 0 and R1, pop. Okay, so there's decrement mode and increment mode, exactly the same as part 1. I just left it in there because, again, some of us benefit by the repetition. But it's the same code. So you could have, if you wanted to, just copy it over. It's the same. And I only subtract when R1 is higher than 0. And in this case, I only add when R1 is lower than 3. That's what the LO means. And then HI is higher. Populate the array. Why these values? I don't know. I guess just to make you think. All right, so this one's new. Hopefully everyone's still doing okay and we're ready to go. I'm going to take a breath. And let you take a breath. Okay, populate array. So we have an array coming in as a variable, which means it's memory, which means that we need to load its address. So I'm going to load its address of that macro variable. Now we just sort of, we know that there's 10 in there, so we're writing the macro with the knowledge that this array has 10 elements in it. So we could do this however we want. I'm going to do the non-updating style. So let's see, we need to move, I'll use R1 for the data. So I will move 5, that's the first value, into R1, and then I will store that value into the array at the 0 offset. So you've seen these before, this is just sort of repeating this old routine from last week. Right, so there's getting the 5 into the first position, and then the second one's supposed to be a 7, That goes into the array, which is the R0 4 bytes over. 4 bytes per integer. The third value is a 3. And then I'll store that into the array at 8 bytes over. That's the third integer. 9. That is 12 bytes over. You can do the updating version if you wanted to here. It's totally up to you. After the 9 comes a 1. Into the array, 16 bytes over. 10 comes next. This just sort of stirs them up, and the reason why we're doing this, by the way, these aren't random, but they're jumbled up enough so that next week when we add some like find the minimum value algorithms to it, at least it exercises the algorithm a little bit. The algorithm will have to search through the array to find stuff. So that's what we're setting up for, is we can use this code next week and write some algorithms through the array just to see what that feels like. 10, 2 into the array, 24 bytes over, getting down to the end there. After the 2 comes an 8 into the array, 28 bytes over. And a 4, almost there. Store that into the array, 32 bytes over. And then a 6. Store that into the array at 36 bytes over, and that's the 36 bytes over. That's the whole array. And then I'm going to push and pop R0 and R1 to protect those registers. So remember, that's what they call in assembly terms the non-updating index mode. So the base address, the starting point of the array, never changes. We just use byte offsets to get to the individual elements in memory. And I just loaded up the data in this order. So those last 4 bytes are the value 6. Saving that. All right, so now might be a good time to go apply the recipe. In other words, let's compile it real quick. Make sure everything's still okay. So compiling this one, we're on main 2 now, so make sure you do main2.s here on the compile step. And of course what we want is no errors. So pretty happy with that still. Hopefully you're not starting to feel the grind a little bit. I am, but I don't think we're that far. So anyway, we have an array now, and we've just populated it with data. We have the buttons, and oh, thank goodness. I did it differently, but in part 2, the display mode has already been done for us, so we don't have to do that, which is wonderful. I hope that's true for you as well. The display mode was already done. In a slightly different way, but I don't care. The other one worked. Is that it? Is that it? No, it's not it. There's more. No. It's okay. We've got a few more to do, but we can do it. We can do it. Okay, we got to clear some bits here. So I'm just going to rely on my memory a little bit. Let's see, we're going to need, well, we need the address GPIO-A output data register to clear these A bits. Get the value that it currently is. And then we're going to need to do some bit clearing. So let's figure this out. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I need 5, 6, 7, 8, and 9. So none of those. I don't need 2 to the 4th. I do need 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th, 2 to the 9th. So my hex is 3E0. Seen that value before. Oops, sorry. So I've scrolled down here to number 11. So I'm on number 11, which is clear bits. Sorry about that. And what I did then is I got the address of the GPIO-A output and then the value from that piece of memory, and then I bit cleared the appropriate bits, and then I'm going to store it back. So that clears the appropriate A bits, and then I'll pause after this so you can catch up now that you can see what I'm doing. And then I also need to do B, so I'll just reuse this 0 here. Get the GPIO-B output data register, get the value off of that. And then I need to bit clear it. I need to do 8, 9, and 10. So I don't need any of these first 7 or 8. So that gets me, okay, so this is 2 to the 8th, which I do need to do, and 2 to the 9th, and 2 to the 10th. Okay, so there's my clearing for the B bits. That is, 7, right? 700, 4, 2, and 1, yeah. And then I'll store that back. And then push and pop the registers I used around it, which is R0 and R1 again. Okay, so I'll hit pause and give you a chance to catch that since I was hiding it for a second. Hopefully everyone's doing okay. This is one of the weird things about doing this on Twitch is that I can't really see who's struggling to keep up and who isn't. So, I mean, I guess there is the video later. You can go back and watch it at your own pace. But if you're just trying to like knock it out as we go, then I'm doing my best to just talk to kill time. So anyway, that clears the appropriate A output bits and the B output bits, which will clear the display. So what we're doing here is we're gearing up to add the 8-bit part of the LED display. So we have the mode part of the display, the one light that changes colors, and we have the buttons that toggle between the modes. And now we're gearing up to actually use the 8-bit LED display to present the values from the array. I'm going to go ahead and do these things. I'm not sure if they're being used, but I'll leave clear bits where we can see it. I'm going to go ahead and do 12, 13, and 14 and explain to you kind of how this is meant to work. So when you see, the way I do it anyway, when you see something that says underscore var on it, that means it's memory. And when you see val, that means it's a register basically, or a literal value. So you're going to see me treat those differently in code. So I'm supposed to make this variable in memory be this value. So the way I'm going to do that, we need to alter this variable. So the first thing we need to do is get that variable's address loaded up. And then we need to grab the current value from it. We don't really have to do that here, but I think it's easier to follow and understand how to repeat the process if we do it this way. So I get the address of the offset variable, and then I get the value from that address. Now I'm going to load up this value. And the reason why I'm not doing the address of it is because it's not a variable in memory. And that's because I know the way I write these macros. If I put underscore var, that's memory, and that means we have to do the addressy thing. If it doesn't say underscore var, then we don't have to do the addressy thing. So in this case, I can literally just put it in a register. Then I can move into R1 that new value. So I'm going to basically overwrite the original value of the offset variable with this new value that's a parameter. And then the last step is I can store the now updated R1 back into memory. Now I actually did an extra kind of unnecessary step there, but I thought you might sort of recognize the pattern better if I did it this way. So I get the current value of that variable, and then I put the new value in a middleman, R2, and then I overwrite the old value, R1, with the new value, and then I store the newly updated value back into memory. And then I'm going to push in pop. In this case, I use more than in other cases, so I used R0, R1, and R2, so I'm going to push all of those, and then pop all of those. I didn't see where this is being used yet, but since it's there, I just decided we should do it just in case it's used somewhere. Okay, number 13. Kind of similar, except for instead of a hard reset, we're doing an increment with an amount. So it's going to look very similar. This one's a variable, which means we have to do the addressy thing. This one's not a variable, so we just load it into a register. I probably could have moved it. Yeah, I want to say, well, let's just see if it compiles. Let's compile. Let us compile. Yeah, it doesn't like that. Cannot represent an offset in this file. Line 149, that was a while ago. Oh, that's not it though. These line numbers don't necessarily mean anything. I promise you the problem is it's right here. That probably should be a move. So for me, that's line 170 in macros 2.s. I'm going to leave that highlighted. And yeah, that was the problem. I noticed that, but then I thought maybe it would compile. So I had to go back to my reset offset, but that's good because I'm going to have to remember this for the new one. Right here, I had a load val into R2, and it needs to be a move val into R2. The line number that I got on the error was totally meaningless because of the way the macros work. Okay, hopefully everyone got that. Line 170 in macros 2.s should be move and not load. But that's helpful because we're about to do something very similar in increment offset. Okay, so offset var, same process. Gonna load its address and then use its address to get its current value. Now I know that I have to move into R2 that amount. And I don't have to do the addressy thing on the amount because it's not a variable. Now I am going to add to R1 that value. I'm not overwriting it this time, I am adding it to it before I store it back. Store R1 back into R0. So they're very similar except for the step where I overwrote R1 and now I increment R1. And then let's do pushes and pops. 0 or 2, pop 0 through R2. I'm going to compile again because now I'm paranoid about that. And I'm going to pause for a sec so you can pit me before I scroll my screen if it's fighting you anywhere. This is a lot of stuff to do following someone online, so it's impressive if you're doing it. And apologies if it's a struggle. Hopefully when we're done, you can go back and use the video to fix up any problems. So please, you have to, if you're watching the video later, I have a compiler error in there. I had to go back and fix some code at a point. So unfortunately, that means you have to sort of be careful about watching the video. But if you're getting a compiler error, then you know something's wrong. So please double check. Reset, offset. Okay, that's good news. And increment offset, everybody. And then run the compiler after each macro and see if you're still. I think we only have one step left before we can see what this new code does. Okay, scrolling down to number 14. I'm not going to worry myself a ton about that, but what are they talking about? Scaled index to load array value into R0. R1 is the base, R3 is the index. I can see that. Use LSL to scale to 4 bytes. All right, so this is a slightly different thing, and we don't necessarily have to do it this way, but what we're supposed to do is basically get, we have to go to this array at this offset and get a value. Now the trick here is that what it's telling me is that the offset is actually not in bytes. It has to be scaled. I'll explain this more next week, but here's what that's supposed to look like. And I'm just sort of slowing down tiny bit. Okay. So this is just a weird thing, but we're going to walk through it together. So basically, I need to load into R0 a value. So this is a slightly different one. We haven't done this style before, but at least you will have seen it once. So the way, when it says scaled indexing, what that means is you give it the base address first. Then you give it the index. Now in this case, when we say scaled indexing, what we mean is that this is like a regular high-level language index. So element 1, element 0, element 2. And so when we say scaled, what you have to do is you use an instruction. It's a logical shift left, but don't worry about it so much. 4 bytes. So what this does basically is it takes the 0-based index and multiplies it by 4. So at 0, the offset will be 0. At 1, the offset will be 4. At 2, the offset will be 8. So this is a fancier way of getting to the right element. You have the base address, you have the high-level 0-based index that you're used to. The first element is element 0, the second element is element 1, and then you have a scaling factor for how big each element is, which is 4 bytes per. So that's what it means when it says scaled indexing, which is kind of neat. But anyway, so that you've seen that before. This is another way of accessing an array. I tend to avoid it, the heavy use of it, because it's confusing to some people. But anyway, R3 is a regular old 0, 1, 2, 3 index. And then the LSL4 is a scale. So this tells you how many bytes is each element. And for us, each element is 4 bytes. So it takes the index and it multiplies it by 4. So at index 0, you're at offset 0. At index 1 times 4, you're at offset 4 bytes. At index 2 times 4, you're at offset 8 bytes, and so on. R1 is simply the base address of the array. And what we end up with then is we go into the array, we grab a value and we load it into R0, which is what it told us to do. So that you've seen that at least this once is one more way you can access array data in ARM. And then I think it does the rest of the work for us. It does. Okay, so I'm going to go back to main 2. And I'm going to see where it's starting the mode at. Okay, so this time it's starting the mode at 0 instead of 1, or instead of 3. And if we scroll down again, this code down here says if we're currently in mode 0, then display the values in the array. So in theory, when we compile this and burn the code and launch the program, it's going to be cycling through the values in the array. And then if we use the buttons to switch the mode, it will stop displaying the array until we return to mode 0. I'm going to then go back to, let me see. Shift out of range. Oh, that's a bummer. Shift out of range. Is that supposed to be a 2? It's supposed to be a 2. It's supposed to be a 2. Sorry. That's a 2. Which again, if I'm thinking, shifting left by 2 is multiplying by 4. So that's multiplying by 4. So again, video people especially, there's another mistake. So hopefully you guys are getting it works if you make that 2. But if you think about it, if you shift something left by 2 is multiplying it by 4. Because every position you shift left multiplies by 2. All right, hopefully it works. So what should happen is it's going to cycle through these array values, which are 5, 7, 3, 9, 1, 10, 2, 8, 4, 6, over and over and over again. And then if we use the button to get out of mode 0, it'll stop doing that. And then if we cycle back to mode 0, it'll restart doing that. So I'm about to give it a try. Okay, so yeah, mine does now compile main 2. Now I need to find that elf part. Elf. bin, burn. All right, I'm about to hit reset, so let me bring up my vertical camera. All right, I'm about to hit reset. I'm not really paying attention to those values, but I'm pretty sure. Let's see, it's supposed to be 5, 7, 3, 9, 1, 10. So 5, 5, 7, 3, 9, 1, 10, 2, 8, 4, 6, and then it goes back around. So I'm pretty happy. So now let's try the mode button. I can't remember which one goes down or up. But if it's, yeah, so that's there. Okay, so I just switched into mode 1, and it's not doing that anymore because it only does that in mode 0. So if I go back down to mode 0, it should start cycling again. And then if I go up to mode 1, it'll stop. And then mode 2, and then mode 3. And then I'll go back down to mode 2, mode 1, mode 0. I hope that's working for those of you who managed to keep up with all that mess. And that was like a pretty good hour and a half of work to get here. So what it should be doing, everybody, part 2, if it's working correctly, when you reset it, should start displaying the values in the array, just cycling through them. We've written that code before, just now we've put it into a more elaborate circuit. And then, I can't remember which one goes up. If you click the button to go up a mode, oh, it's this one. Oh, there it did. Okay. If you click the button to go up a mode, then the mode display changes. Now, mine's blue. You can't tell that on the video probably. And the cycling stops. So I'm in mode 1. If I go up again to mode 2, this one now for me turns green. No cycling because I'm not in mode 0. Mode 3 is the combination of the two colors. And then I can use the other button to go down to mode 2, which isn't doing anything. Mode 1, which doesn't do anything. Mode 0, which cycles the array. So now we have a multifunction display. The final lab is adding functionality to modes 1, 2, and 3. So we have functionality for mode 0. Next we need functionality for modes 1, 2, and 3. What we're going to do with those modes is we're going to say display the maximum value in the array in one mode, display the minimum value of the array in another mode, and display the average, the integer clipped average of the array in the final mode. Okay, that was tough. These are hard to do. That's if you manage to get something working, following along with me in real time, then damn, that's good, because that's quite difficult to do. So good on you if you managed to do that. If you didn't, then the video is going to be posted, and you can email me if you get hung on something. So compile, and then ultimately test the circuit, and try to make sure that it's doing what you want it to do. Otherwise, I think we're done. So again, as always, I'm feeling pretty satisfied because this is not easy to do, and it's awesome when it works. So hopefully you feel that way about your result as well. Anyway, I'll sit here and I'll field questions for a couple minutes. Otherwise, I hope you have a great weekend. We are down to one more full week and then one more day after that. So I'm glad that almost all of you in this class stuck it out to the end, because this is not the easiest format to survive in. And I hope that somehow you come away with something that you can use from this class. Even if it's only that you recognize hex values, that's better than nothing. But maybe just having some insight into how processors work, sort of at the lowest level, may also come in use at some point. And I think that's it. Oh, Vince, I don't know if you're still here, Vince, but I saw an article about the valedictorian at Princeton University, and he's all about like bioinformatics and stuff. He's like all over that kind of stuff. So I thought that was pretty interesting. That seems to be his main area of interest. Okay, thanks again. Have a great weekend. I'll see you on Tuesday morning, I hope. And otherwise, I'm going to shut up and sit here for a couple minutes and field questions if there are any. It is. I'm even starting to think about doing something along those lines, Vince. Um, it might be part of my, maybe I'll semi-retire because it's very, very interesting. I mean, there's just so much interesting, like population level data and data at the individual level when you're looking at what's going on right now. I think it's potentially pretty exciting.